Now here we will derive the angle between two lines whose direction cosines are known. So to find the acute angle theta between two lines whose direction cosines are L1 M1 N1 and L2 M2 N2, the formula is given here, that is cos theta is equal to mod of L1 L2 plus M1 M2 plus N1 N2. Now let's see how to derive this particular result. Okay. For that, let's consider that these are two lines and the angle between them is theta, right? The direction cosines of the two lines are L1 M1 N1 and L2 M2 and N2. Now here we imagine one unit vector in the direction of first line, let us call it as E1 cap, and a unit vector in the direction of second line, let us call it as E2 cap. Since the two unit vectors are parallel to the given lines, so the angle between the unit vectors must also be equal to theta, isn't it? That is quite logical. Now what do? Is we calculate the theta with the help of the two unit vectors now. Okay. Now once again let us recollect that if we have a unit vector, then its I, j and k coefficients are nothing but the direction cosines of the line in the direction of that particular unit vector, correct? So that means we have E1 cap to be equal to nothing but L1 I cap plus M1 j cap plus N1 k cap, correct? So L1 M1 N1, which are direction cosines of first line, they will be nothing but the coefficients of I, j, k in E1 cap. Similarly we will write, we have E2 cap must be equal to L2 I cap plus M2 j cap plus N2 k cap. Alright, now we know that the angle between two vectors with the help of dot product, we write that as cos theta is given by E1 cap dot E2 cap divided by mod of E1 cap that is magnitude of first vector into magnitude of second vector. Now we know that the magnitudes of E1 and E2 cap must be 1 because they are unit vectors. So therefore what remains is just to calculate their scalar product, that is E1 dot E2, and that is calculated by multiplying the corresponding coefficients of those vectors, and which are nothing but L1 L2 plus M1 M2 plus N1 N2. So therefore here we get the required relation, that is where we have L1 L2 plus M1 M2 plus N1 N2, and that is what is the required expression. Now we are taking the absolute value of this expression because we want to know the acute angle between them, and hence the cos must be positive. So therefore we are taking the absolute value. So therefore this is the required expression to get the angle between any two lines whose direction cosines are known. Now the question comes to our mind that what if instead of direction cosines, if we know the direction ratios, that is A, B and C's of the two lines, in that case how do we find the angle? So this is where we see the next one. So in that case the formula for cos theta is as shown here, that is A1 B1 C1 and A2 B2 C2 are the direction ratios, then this particular is the formula. And the proof of this is rather straightforward. What we consider is, look at this first particular term, A1 upon root of A1 square plus B1 square plus C1 square. We know that this is equal to L1 because we have seen how to convert direction ratios into cosine. Now that multiplied by A2 divided by the second square root, which is nothing but L2. isn't it? So similarly, we calculate the remaining terms, which are nothing but m1, m2 and n1, n2. And we have already proven the second result, that is, we have already proven the formula in terms of LMN. So here we work backwards and replace L, M and N in terms of respective A, B and C's to get the formula mentioned here.